Good evening, my YouTube viewers. What we're going to talk about in this video is how many boxes of defective batteries do you have to open to determine the average number of defective batteries contained in a box. And what we're going to do is we're going to write a program in Python to solve this problem. And before we write the program in Python, then what we're going to do is we're going to import two libraries that are going to help us to execute the program. So the first library that we're going to import is math, which is an inbuilt module in Python, so you don't have to install it. When you install Python onto your computer, math is installed with it. And then the next thing we're going to do is import scipy.stats as stats. Scipy is Python's scientific library, and stats is a statistical element within scipy. So after we have imported our libraries, then what we do is we set up our parameters. So the confidence level is 0.95, the margin of error is 0.3, and estimated standard deviation is 0.9. So what we have to do, the first thing, we have to calculate the z-score for the desired confidence level. So z-score equals stats.norm.ppf, and it'll be 1 plus confidence level divided by 2. And norm means it's a normal distribution, and ppf means it's percentage point function. So we're going to calculate the z-score as being 1.959 or 1.96. And then after we've calculated the z-score, we're going to calculate the sample size. So the sample size equals z-score times estimated standard deviation divided by margin of error to the power of 2. So I calculated that on a calculator, and it's 34.5744, what I calculated. And then we're going to round up to the next whole number, since you can't open a fraction of a box. So we rounded it up to the next whole number, and it's going to be 35. And then we print the number of boxes to open to determine the average number of defective batteries with a 95% confidence level is a margin of error of 0.3 is 35. So what I calculated, 34.57 and rounded up to 35, is the same. So that just proves that what we have done is we proved this function, but we proved it. We did it with a calculator. I had to use the z-score because I don't know the formula for the z-score right off the top of my head. So I had to use scipy's normal distribution to calculate the z-score. And the normal distribution is also called a z-distribution, and that's why they call it a z-score. But I did calculate the sample size on the calculator, so you can see for yourself that when you calculate the sample size, it works. So that concludes this video. The next video is going to be on a political pollster, and I hope that you decide to watch it.